6, 7, 8, 9, 10. All right, so our first inequality that we got was 4x plus 7y. And it was greater than, strictly greater than 800. All right, now a couple things to note here on our Desmos graph. So you could see as I was typing that in, some things were happening on the Desmos graph behind me, but now you notice that it looks like it all just disappeared. Well, the problem here is, since we're having the computer graph for us, we're not finding out any of the information that we typically would when we graph by hand. So, if we were graphing 4x plus 7y is greater than 800 ourselves, we would have probably found x and y intercepts to plot on the graph. But in this case, we didn't have to do that because obviously Desmos will just graph right away. The issue is that looking at the Desmos screen, you can see that off to the side here, the highest x value is positive 10, the highest y value is positive 6. And if we actually found x and y intercepts, we're looking at numbers in the x case at 200. So what I'm actually going to do is, if we click on this little wrench button over here, we can rescale the x and y axis. So maybe I change this to we'll just play around and put 400 in. You can see now, obviously that was way large enough because there's 200. So I'm going to drop that down to maybe 250. So we can see a little past that. Our y-axis, we still don't see that point. So again, let's try 150 and see if that does it. There we go. So now you can see that our graph is kind of scaled to numbers that work well for the inequality hand. And you can do that again. All I did was come over here and click on the little wrench button, and then there's some things we can do in here. I could also mess around with this step option. Allows us to tell Desmos what to go up by on the x and y axis. You can also put a label in if you were going to, submit this as a type of graph that you wanted to share with someone else so they knew what the x and y variables represented. For now, I'm going to leave this alone. And basically, what this allows us to do is now, again, it takes the graphing aspect out for us, so we don't have to do that ourselves. But now we can kind of take a look at solutions in this case. So notice that Desmos knew the line here should be dashed because there's no equal to. And then it also did the shading. It took that step for us. But what it doesn't do is interpret the context. So if you recall, the question was asking about selling candy and candles. And maybe I'll write those variables back over here. So X was candy and Y was candles. So, and we were talking about the Boys and Girls Soccer Club needing to raise money for selling uniforms. So, potentially what they could ask you is to tell me if a specific ordered pair was a solution, or they could say, hey, give me a solution or 2 or 3 or whatever that would actually work here, or the opposite, something that wouldn't work. So, obviously with shading, anything that's out in the shaded region is going to work. So if I just pick a pretty point, maybe this one right here, that's at 100, 100. There we go. Our point right here. What that implies is that if the boys and girls sell 100 boxes of candy and 100 candles, then they will have more than $800 because it's in this shaded region, in the solution area. Some other things to keep in mind is that the line here is a point of reference that we should talk about. If I found a point that's actually on the line, and a pretty point that I can see right away is down here at 200, 0, would that be a solution? Well, if I plug in 200, 0, so we'll do 4 times 200 plus 7 times 0, we're questioning, is that truly going to be greater than 800? We'll get 800 here plus 0. So we get 800 is greater than 800? And the answer is no, it's not. So that's why our line here is dashed. It's not going to be part of the solution set. So some things to think about is, obviously, If you're approximating here, you don't want to pick a point. Like I wouldn't pick this point right here or something super close to the line. Like don't pick a point that you're unsure of. Obviously, you can plug in the values like I did as the example there and check it. But if you're just picking random points in the shading, notice how the first one that I chose was out here at 100, 100, clearly off of the dashed line in this case. The other thing is the opposite. So they might ask you, well, what wouldn't be enough? And maybe you would say down here at 50-50. That's not going to work. If they only sell 50 boxes of candy and 50 candles in this case. So just be cautious of that and know what you're working with here. But obviously in this case, anything in the shaded region would be a solution and would make the inequality true and would work for the scenario. Anything on the line in this case, as well as in the non-shaded area, would not be a solution here.